So another rule that often is useful in finding the limit of a sequence is the composite limit rule. I'll just write that name here. It's the composite limit rule. This is basically the rule that you learn that says things like the limit of a log is equal to the log of a limit. It allows you to bring the limit inside a function when you have a composite function. So here, what we have is we have we have the function we have the number e raised to some function. So you can think of this as sort of like like f of x equals e to the x and g of x equals 3n over n plus 1. So this is kind of like f of g of x. It's a composite function, but kind of in disguise because the inner function is in the exponent. You would have learned this principle when studying the chain rule. This example has absolutely nothing to do with the chain rule. I'm just saying that's another situation where composite functions tend to come up in calculus. Anyway, just want to demonstrate sort of what the technically correct way to do this is. What we do is we find the limit as n approaches infinity, because of course that's the only type of limit we care about, of e to the 3n over n plus 1. That equals, we're going to now bring the limit inside the function. So this is going to be e to the limit as n approaches infinity of 3n over n plus 1. And now I can evaluate this limit just using the rules that I know for polynomial, for limits of rational functions of polynomials. I can either just multiply by 1 over n, or I can simply observe that the degree of the numerator and denominator is both 1, so I just take the ratio of the coefficients of each of the highest powers of n. So that's going to be, let's do it the formal way. Let's say it's e to the limit as n approaches infinity of 3 to the n over n plus 1 times 1 over n over 1 over n. And that's going to be e to the limit as n approaches infinity of 3 over 1. I'll just write that a little clearer. That's n plus 1. 1 plus 1 over n, which is e to the 3 over 1 plus 0. That simplifies to e cubed. So that's a fairly simple example, but I just wanted to demonstrate that technically what we do in this situation is we're bringing the limit into to the inner function, and we can do that by the composite limit rule. Um, in general, because sometimes it gets a little messy to put this limit symbol in the exponent, I'm not going to do that. But just know that this is technically the correct way to think about the algebra.